So today we're doing polar system to Cartesian system and vice versa. So converting polar equations to a rectangular system. So we did polar coordinates yesterday, or the last video. So the same conversions apply that we figured out yesterday. We might need to tweak them a bit to figure out which one we want to use, but same basic ideas. So to convert this one, we want to use something down here to get to an xy system. So I have nothing that equals just r, but if I square both sides and get r squared equals 9, now I can use this right here and get x squared plus y squared equals 9. Now I've gotten rid of the r and the theta, and I'm good. So to go to Cartesian coordinates, you need to have no r's and no thetas left. So if we do another one, here, r cosine theta equals x, so we get x equals 8. I got rid of the r, I got rid of the cosine, done. It's now in rectangular coordinates. Okay, this one's going to be a little bit more complicated. So I don't have anything equals r, and I only have a cosine, so it'd be nice if I had like an r squared and an 8r cosine. So I'm going to multiply everything by r to get r squared plus equals 8r cosine theta, which then will give you x squared plus y squared equals 8x. Now, in your book, this is an equation of the circle. It's going to complete the square and give you your standard equation. For our purposes, you can stop here. This can be your answer. You can be done. You don't have any r's, you don't have any thetas, you don't need to solve for anything. But just as a little refresher, to complete the square, the y squared will stay the same. And I'll switch colors for this. We'll have x squared plus 8x plus y squared equals 0. Clump these two together. And then add on your b value here divided by 2 squared. So you want to add on 4 squared. Then you also need to subtract that, or subtract that from the other side, like that. This is then going to factor to x squared plus 4. And then you have your y squared, and we get 16. And that is your completing the square function. Except I noticed this should be negative all the way through because I subtracted the 8x over. But otherwise, same idea. But again, you can stop at the blue and leave it there. Okay, so you try converting both of these, and then we'll talk about it. Okay, the first one, again, I can't do anything with just sign, so I'm going to get it out of the bottom and multiply over. So we get something like this. Now y equals r sine theta, so you can get y equals 8. And then over here, it looks like it'd be nice to have an r with each of these. So I'm going to multiply everything by r to get r squared equals 6 r sine theta and 6r cosine theta. So then x squared plus y squared equals 6y plus 6x. And then we should complete the square and get a standard form, but I'm going to skip that. Okay, so if we can just convert back and forth, why even use polar coordinates and polar equations and everything? Doesn't really make sense. So for this one, considering if you switched it back, don't try it because it's going to be super long, you would get this equation. So you'd get x to the 4th plus 2x cubed minus 3x squared plus 2x squared y plus xy plus x y squared minus 4y squared plus y cubed, I believe, equals 0. So super long, super complicated, not worth doing. So some equations are much easier in polar coordinates, which is why we use them. Okay, so this one, now we're going to be going into polar coordinates. So from rectangular to polar, here You're going to switch, so you have no x's and y's, only r's and thetas, and then you need to solve for r. So for rectangular, you don't have to switch and solve. For this one, once you switch, you need to solve for r. So y can be written as r sine theta equals 5. Get r by itself, you get 5 over sine theta, and then r will equal cosecant, or 5 cosecant of theta. And that's your answer. Here's another one. So 3, replace the x with your r cosine theta, y with your r sine theta, all equaling 2. And then we need to solve for r still. So you can factor the r out front and get 3 cosine theta plus 4 sine theta equals 2. R equals 2 divided by 3 cosine theta plus 4 sine theta. And that's your answer. Okay, one more example. So here you have two options. You can either FOIL this out, well, it's still x's and y's, or you can convert everything first and then FOIL it out. It doesn't really matter which you do first. I usually prefer foiling it with x's and y's since then there's less cosines and r's and thetas to deal with, but it's up to you. So you get x squared plus y squared plus 8x plus 16 equals 16. These 16s will cancel, so you get x squared plus y squared plus 8x equals 0. Then this chunk becomes r squared, and then you get 8 times r cosine theta equals 0. Okay, factor out an r, because we need to solve r by itself. And then if I divide by both sides by r, that cancels, and this just goes back to 0. So you get r plus 8 cosine theta equals 0. Then r is going to equal negative 8 cosine theta. And that's your answer. 1 second. That should be a y right here, all the way through, which changes this to a sine. Making all the mistakes today. So this should be a sine theta in the end. And that's your answer. And then go on Schoology to figure out what the assignment is.